We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRAE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRAE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRAE helps formalize industry codes and standards. ISHRAE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRAE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRAE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRAE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, ISHRAE India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The ISHRAE exhibition is now growing from HVAC and R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like ISHRAEConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A prestigious quiz competition organized by ISHRAE to catalyze the transformation of the budding engineering professionals. ISHRAE provides a platform to potential employers to select student members for careers in HVAC and R industry at the ISHRAE Job Junction. Young minds are made aware of the need for saving power, clean air and sustainability. The K-12 initiative of ISHRAE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection and energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ISHRAE.in that unfolds a panorama of information Let us engineer a sustainable future together through ISHRAE.
So good afternoon, everyone.
Good afternoon.
So I'm actually seeing how many participants have joined. Let me see. Purnima, are they gradually joining?
Yes, ma'am. Mostly students who join.
They'll join, right? Yeah.
Yes.
So good afternoon. Today, as everybody knows, today is a National Engineers Day. And I don't know how many. How many of you know it is a national day, National Engineers Day, and it is celebrated today on 15th September. Basically, it's a birth anniversary of our Bharat Ratna Moksha Ganam Vishweshwara. He was one of the well-known famous engineer, and he was from before the independence. He was there. He was quite recognized by all. His work is quite recognized. He has developed many things. He has developed dam gates and many things which are because of that he got Bharat Ratna. And the today days is actually observed that we all engineers, we are it is to improve us and so that we can innovate many things. So that's why we have planned this competition for Engineers Day, so that we can see how innovative are our new upcoming engineers and what projects they are coming up with. And so I want to welcome you, the teachers who have encouraged the students, Ashish sir, who is the Delhi chapter, president of Delhi chapter of ISHRAE, all our judges, and all our participants. So can we start now? Will that be okay? Everybody's there. Purnima, can we start now?
Yes, maybe mostly student already have joined. So
because I want the attendance should be there, because otherwise, fine. So okay. So now पूर्णिमा आशीष सर तो नहीं है, मैं आशीष सर बोलूं कैसे?
मैम
हेलो, मैं जजेस का बोलूं फिर आशीष सर का बाद में बोल देंगे?
आशीष सर ज्वाइन कर रहे हैं अभी 2 मिनट्स में। आप जजेस को पहले कर दीजिए इंट्रोड्यूस।
So actually, I would like to welcome all our judges. Our judges today are Amit Kaushik ji, Akshay Saxena ji, and Mohammad Adan ji. So they are all of them are CWC members. So Amit Kaushik ji is a 45 years young man, mechanical engineer by profession. He has passed B Mechanical from MIT, Manipal. And he's having 25 years experience in HVAC industry. So his experience is in installing and commissioning of HVAC systems, and he has a sound knowledge of HVAC fundamental and business operation and ability to perform troubleshoot on HVAC and building automation system. So I want to welcome Amit ji and the other judges, Mr. Akash Saxena. So he is sales and project manager of Ventilator Air India Private Limited. He is working professional in the HVAC industry with expertise in ventilation, air conditioning, dust collection systems. With over 4 years of experience, he has completed various projects across India. He has been handling the projects of Ventilator India Private Limited. Ventilator is one of the leading manufacturer for fans and blowers. And he is master's in business administration with the specialization in marketing. Along with that, he is also engineer in mechanical, in the field of mechanical. So I want to welcome you, sir. And the last judge is Mohammad Adan. Mohammad Adan ji has completed engineering from Gautam Buddha Technical University. He is working in Abid Hussain Consultants since 2012. During his professional career, he did many reputed and iconic buildings throughout the country, and he's still doing that. Throughout his professional career, he remained very innovative in design and selection of systems and equipment. He was amongst first few to adapt primary variable pumping system. He has designed different types of projects like airport, hospital, clean room, data centers, commercial complex, universities, and hotel. He's ISHRAE and ISHRAE member both. So I would like to welcome you all. And I would like to welcome Ashish Gupta ji, sir. He's president of DCI. And he is Director, Standard Refrigeration Private Limited, more than 31 years of experience in HVAC industry. HVAC industry, commercial refrigeration, bulk cooling, and industrial refrigeration. NHB training course. He has also done NHB training course for graduate engineers for the cold chain of technical proficiency regarding planning and design of cold chain infrastructure. ISHRAE certificate course from in September and December 2011. He has done that. He has done training at Emerson, China for compressor tear down and rebuilding seminars and trainings by Alpha Emerson, UVIE, and Dixlick. So I welcome you, Ashish ji, and I would like that if you can encourage the students today on this very special day of Engineers Day, National Engineers Day.
कामेश से बात करी थी ना, देगा प्रेजेंटेशन वो.
Thank you, Priyanka ma'am. Thank you so much for always supporting students and encouraging students for the activities. A warm good evening to all the students who took the effort to be part of this initiative today. I would just like to say my thought process in probably just one statement. While I would like to congratulate you on the Engineers Day, is that rest of the world have a problem statement. कैसे होना है, ये क्या करना है. Engineers are the only one who have a solution statement. It is said more than often that you give engineer a problem and he will find a way around it. So engineers are the building block of any progress that the mankind has been doing from the times that we found fire and made the wheel to the point that we are now going to the Mars and beyond. So please take pride in what we are, what we aspire to be. इंजीनियर्स के बिना ना तो ब्रिज बन सकते हैं, ना हमारे फोन चल सकते हैं, ना हमारे घर का खाना ठीक रह सकता है, सो ना बिजली आएगी. सो ऑल द प्लेसेस engineers are required. Most of the innovations, in fact, almost all the innovations are done by engineers. Realizing that you have the potential is very important. But the only thought that we wanted to do today was कि हम एक thought process है जो कि out of the box सोचने का है, जिसे I personally feel that all engineers should start thinking, and that is why we took the आज का जो theme हमने लिया, it was on around that how we put engineering, apply small engineering fundamentals into our daily routines and make our lives better by by the efforts. So my all the best to all the students who have taken the effort. Judging is a prerogative with the judges, and I can assure you that they are the most impartial people I know. Winning and losing is an important end result of any of the competition that happens. But more than winning, it is important that you all have taken a part, taken the initiative, and from where I see, you all are winners. You all are amazing engineers, and sooner or later, you will make this country proud. With that, I congratulate all of you for taking the effort on this Engineers Day. And again, there'll be one winner. My congratulations to all the winners. But for me, whoever is on this program today is a winner. Thank you so much. Purnima?
Yes, sir. आगे proceed.
Yeah, so can you take the proceedings further?
Yes, sir.
I think it's time to presentation from the student side. The first name that I have got is Naman Sabrawal. Mr. Naman Sabrawal, are you ready?
Ek minute, Tapas, for the sake of just clarity, I would request if everybody, you can read out the, reiterate the rules that we made for today's, competition. Just to, obviously, sabko bata chuke hain, but just, sake of clarity, if you can read out all the rules for the competition.
Actually, sorry, again, I'm, so I will just read out the rules for the competition. Am I audible, sir?
Yes, ma'am, you're perfectly audible.
So for today's competition, we will be judging over your project, what project you are coming up with, your communication skills, presentation skills, and we'll be marking over the your project or the presentation of the project also. And there is a negative only one negative marking here. So I wish you all the best and would like to call upon our first candidate.
So Tapas, from here, you can please, call the person every time. And
Yeah, because
also,
I'm actually
yeah, fine, ma'am.
Sort of internet issue,
yeah. And so is there a clock that is going to come on the screen, Tapas, so that everybody knows about it, or how are you doing it?
Yeah, there is 7-minute time, so we'll look after
so, yeah, so after once the 7 minute is like at 6 minutes 50 seconds, please give a signal to the speaker. Okay. All the best, team. Start with
so
it.
I request first Naman Sarwal to proceed from here with your presentation. Over to you, Naman.
Thank you, sir.
Yeah, please share the screen from your side.
Yes, sir. I'll just do it just now. Is it visible?
Yes, it's fine. Yeah.
Yes, fine.
Good afternoon, everyone. So I have done a project on design of flywheel, a design of flywheel for improved energy storage. Is it visible? I'm just reconfirming this.
Yeah, it's fine. Yeah.
You can run the full presentation mode if you can. It will be better.
You can
Yes.
go to the slideshow mode.
No, sir. Actually, I'll be just reading it out basically. So
Okay,
flywheel.
okay. No, it's okay. Go ahead.
Yes, sir. Yes, sir. So the flywheel, sir, is basically is like a rechargeable battery, which absorbs electrical energy from a source, and it stores kinetic energy of rotation, and then it delivers it to a load in appropriate time. So this is basically an introduction about flywheel. I won't go into the details because the main thing is about the improvement in the system. So I'll just go to the next slide. This is the theoretical analysis. Basically, half I omega square, the energy is stored in as in the rotor as kinetic energy as half I omega square. So the moment of inertia of a solid cylinder here will be half mr square. For a thin walled cylinder will be half mr square. For a thick walled cylinder will be half m r1 square plus r2 square. So these are the notations. We don't need to know the notations. It's very easy. So the amount of energy of that can be safely stored in the rotor depends on the point at which the rotor will warp or shatter. The Hoops stress on the rotor is a major consideration in the design of a flywheel energy storage system. So sigma T is equal to rho r square omega square, where T is the tensile strength on the rim of the cylinder. Rho is the density of the cylinder, r is radius, and omega is angular velocity of the cylinder. So recent developments. Mission critical technology programs are recently focused on storing energy in a more efficient way using flywheel than rechargeable chemical batteries, while also providing some control advantages. Flywheel is essentially a simple device for storing energies in a rotating mass, has been known for centuries. It's only since the development of high strength materials and magnetic bearings that this technology is gaining a lot more attention. Exploration of high-strength materials allows designers to reach high operating speeds, yielding more kinetic energy. Using magnetic bearings make it possible to reach high operating speeds, providing cleaner, faster, and more efficient bearing equipment at extreme temperatures. So recently designed flywheels could offer orders of magnitude increases in both performance and service life, and in addition, large controlled torques and momentum storage capability for spacecraft, launch vehicles, aircraft power systems, and power supplies. The flywheel system mainly consists of flywheel rotor, motor, generator, magnetic bearings, housing, and power transformation electronic system. In the development of flywheel, current researchers have focused on increasing the performance while meeting the safety considerations, that is, material, housing, and bearing failures. Investigation of energy storage and failure considerations start with calculation of kinetic energy. So the newly proposed design is as follows. Proposed fully parametric model shown in figure, where I is the thickness, 5.08 centimeters, and the radius of the flywheel is about 14.605 centimeters. Two-dimensional flywheel geometry is constructed with a total of 10x coordinates by varying coordinates 1 to 8, only in A direction to be less equal to H. T-axis shows the axis of rotation according to the right-hand rule. Although many materials with better strength and lower density are available in the market to serve the purpose of the study, an example material property of AISI 1006 steel, cold drawn with modulus elasticity of 205 gigapascals, density of 7.872 grams per centimeter cube, Poisson ratio of 0.29, and yield stress of CV 219 megapascal is adapted in all cases. This is the model which had been described here. Although there is an infinite number of a possibility of 2D cross-section selection, the procedure outlined in the previous section applied to first solid disk as base 2D geometry. Next, the annular disk geometry is chosen with an inner radius of 0.1016 meters. In the test runs, using various inner diameter sizes performed worst in terms of high stress levels, even at lower rotational speeds. Therefore, only single configuration is documented here. Third and fourth cross sections are chosen out of concave and triangular shaped functions respectively. Final cross section is selected to be composition of convex lines. So the whole testing process is divided into 4 steps. 5 different flywheel designs are made. A program is made to compute the maximum angular velocity that each design can handle. Step 3, maximum kinetic energy and specific energy of each case are found out. The best design is found comparing the specific energy of each design. So the design which has the most specific energy is our most efficient design. These are the first 3 designs here. And these are the next 2 designs here. So these were the following results.
Naman, just recalling you, you have only 1 minute left. So.
Yes, sir. I'm just finishing. Last 2 slides. Examining the results shows that using the annular solid disk flywheel yields the lowest specific energy performance no matter what the inner hole radius is chosen. Solid disk performs better than the annular disk, but highest shaft load is expected since the flywheel mass in this case is the largest. By adopting simple modifications to geometry, flywheel specific energy performance could be improved as demonstrated in case 3 through 5. Especially in case 5, performance of flywheel performs 50% better than case 2. One more thing to note that case 5 cross-section also exerts fewer shafts load than case 1 through 4 since its mass is the smallest. Although this improvement is to be thought small, it still could be crucial for mission critical operations which require long-lasting service life and efficiency. That's it, sir. I conclude here.
Thank you, Naman.
So shall I stop sharing screen?
Yeah, you can stop.
Thank you, sir. Thank you.
So Naman is from Delhi Technological University. Now we would like to invite Mr. Yash Srivastav. Mr. Yash is there from Sanskriti. Okay, another name from Sanskriti is Mr. Tarun Singh. Is Mr. Tarun is there? Tarun Singh.
मे बी अभी तरुण ने ज्वाइन किया था, मैं एक बार रिकॉल कर लेती हूँ शायद अगर है तो पॉसिबल.
So should we wait or move ahead for another contestant?
Please take the next candidate. Don't let him join.
Okay.
Yeah,
So moving to the Department of Civil Engineering, IIMT. First candidate is Sarthak Jain. Is Mr. Sarthak is there?
I think he's not here.
Aswani Rai, Mr. Aswani Rai.
Yes, sir. I am available, sir.
Okay. So just I'm giving you to the share screen. Just a minute. Yeah, please go ahead with share screen. Share your screen, Mr. Ashwini Rai.
Yes. Sir, is my screen visible now, sir?
Just a minute. No,
Okay.
still it is not shared.
Is my screen shared now, sir?
No, I think you will have to reshare.
One second. Is it visible now, sir?
No, still not.
I hope it is visible
Yeah,
now,
yeah.
sir.
Now it's coming. Now it's coming. Please go to the slideshow mode
Yeah, sure.
for better visibility. Yeah, it's fine now. So
Yes, sir.
it's 4:33, and your time starts now. Please go ahead.
Yes. Yes. Good afternoon, everyone. The subject of my presentation today is concrete durability and its environmental impact. I have four different objects in my presentation. Number one, we will briefly touch upon the overview of porosity and permeability, which impacts the concrete durability. We will also see what are the measures we can take to enhance the concrete durability, some of the performance benchmarks, and the environmental impact of the durability of the concrete. Now, in civil engineering, sir, we all know that concrete is the most widely used materials, whether it is water treatment plants or it is bridges or dams or highways. Nowadays, concrete is most widely used in almost all of the structures which are coming around us. Concrete from the outside, although it looks very rock solid and strong, but internally
Ashwani, your voice is breaking a little bit. Hello.
look at
Ashwani, you are not audible. I mean, your voice is breaking. Yeah.
macroscopic view. Will find the composition of concrete, which is made of a
I think Ashwani has disconnected due to the low network. Ma'am, should we wait for to reconnect him?
Yeah, we can wait for 1 minute at least. He was with the,
Okay,
in the yeah, 30 seconds. If he'll not join, then we can give him the chance later.
okay, ma'am. Ma'am, still, I think Aswani is not able to join. So,
So you can give the
should
chance to
we
another.
wait for, should we go to the another one, another contest?
एक काम करिए, Ashwini, I don't know if you can hear Ashwini or not. So maybe you can find a better location where you have a better bandwidth.
Yeah, now he connected. Aswani Rai connected. Aswani, can you hear us? Hello. Ashwani Rai, hello.
Ashwini Rai is taken the as a host, so maybe he's connecting. Let's just give us 10 seconds more, then we will.
Okay, sir.
Yeah, sir, am I audible, sir?
Yeah,
Yes,
you're
Ashwini.
audible.
Yes.
Yes, ma'am.
Ashwani, your screen is visible. Can you please share your presentation? I think there is still some internet issue or something else. Hello, Ashwani, can you hear us?
Tapas, I think.
Yes, right, sir. I will just restart, sir. So the network was a bit
Your
down.
screen is visible. Your screen is visible. Can you share your PPT? I mean, go ahead.
एक काम करें, एक मिनट. What we'll do is Ashwini है ना नाम?
Yeah.
अश्विनी, आप एक काम करें, आप प्लीज पूर्णिमा को अपनी प्रेजेंटेशन मेल कर दो, हम यहाँ से करेंगे और आप अपना वीडियो ऑफ करोगे तो आपको ज्यादा बैंडविड्थ मिलेगी और आप ऑडियो बोलिएगा. टिल दैट टाइम, व्हाट यू टाइम, आप पूर्णिमा प्लीज उनसे कनेक्ट करके आप प्रेजेंटेशन ले लो, तापस को दे दो. आप तब तक तापस नेक्स्ट प्रेजेंटर पे चलते हैं एंड देन विल कम बैक टू हिम अगेन. ओके
Okay.
Okay, sir.
Okay. So we are moving to the ABS University. I request Piyush Kushwaha to present your PPT. Just I'm transferring the host power.
Sir, I think we miss Lucky Sharma.
Lucky Sharma.
Lucky Sharma is not available.
Lucky Sharma, I think is he available here? Actually, I have searched the name but not found
No,
that.
no, sir, no.
No problem. Then let's move to the next.
So just yes, Mr. Piyush Kushwaha, please go ahead.
Yes, sir.
Please go ahead
I'm
with
visible.
your share screen. Yeah, please share the screen and start your presentation.
Sir, my screen is visible.
Just coming, just wait. Yeah, it's coming. Yeah. Please go to the slideshow mode and it's 6:42 and you will have to end up by 6:49.
ये
Please
कौन
go
सा
ahead.
टाइम जोन में चल रहा है? तो 6 के बार
Sorry, 444 or 442.
Yes, sir. Yes, sir. Good morning, all of you. I am Piyush Kushwaha from ABS Engineering College. I'm mechanical department. I am member of ISHRAE. Delhi chair my project about 3D printer. I made a 3D printer, and a 3D printer basically a machine that will think. It's just like a put of track manufacturing. What we do, we have a the part we build. We have to bigger than that, and we have to machine that part and require energy to recycle. And but in material which is required to build the part is 3D printing can be in plastic or metal 3D printing, sometimes ceramics also. So it's additive manufacturing. Now, so here's my journey from idea to my real 3D machine. And first I start, as you all know, I think, so in which we prototypes. So first I started with basically 3x and z axis, and then build the whole frame upon that. And CAD software helps development in analysis and manufacturing also a lot, and it improved the accuracy of the process, and it's a very nice thing. Now assembly of 3D printer. So almost 1 month almost. So I optimize many design and come this design, and these are all 3 axis rods and all, and assembly was took about 2 months almost. Many 3D printing, it's a open source. It has a huge community. So if we have any problem there, and somebody in the world around any corner help us. So after like my machine was built, so you can see a hot end is like has a high temperature around 300 degrees Celsius, 200 degrees Celsius, and it melts over time. So all these things have and create a 3D object. No, it's a PLA. Engineering material are like CF, nylon, huge variety of filaments. I again thank all huge design committee of desktop 3D printing. It helped me a lot. And now coming to why I'm like a very nice thing. So 3D printing can turn manufacturing to local, like it doesn't have to so far, and and it can create very complex shapes also. internal shapes, and which we can't achieve. And 3D printing can make hands, and prosthetic hands are very expensive. Prosthetic hand are one can't buy those expensive things. So 3D printing can 3D print could save environment, as we see in CNC. We create a lot of waste. We accept recycled material.
1 minute left.
And like main filament plastics. So it's good for nature, and it's printing for sustainability. 3D printing can actually highly, with 3D printer we can achieve in this figure. It is a heat and exchanger, and you can see its internal are not in direct contact, but they transfer heat very complexly and can create these type of products. Heat exchanger, it's complex internal shapes it has, and high fluid pathway and 3D surface feature, resulting in high thermal exchange and low weight, low pressure drop. And we see in G aviation. G aviation is a 3D printed nozzle for a fuel injector. And its weight was reduced to 21%. It's a very huge achievement for me. For us, for whole world. Thank you. That's all from my side.
Thank you, Piyush.
Just one thing, Tapas, was I having a problem in listening to Piyush? Yeah, everybody else was also having a problem listening to Piyush.
Sir, everybody, sir.
Everybody was having problems, sir. Myself, Mohit, sir. Good afternoon, Mohit Bansal from ABS, his faculty. सर मैं आपसे बोलना चाह रहा हूँ कि इस बच्चे का काम बहुत अच्छा है, और थोड़ा इंटरनेट कनेक्टिविटी ना, आज थोड़ी वेदर कंडीशन यहाँ पर क्लियर नहीं है गाजियाबाद में, तो हमारे कॉलेज में इंटरनेट पुअर है. अगर आप कहें तो मैं अपने पर्सनल इंटरनेट से इसको दोबारा कनेक्ट कर सकता हूँ, बिकॉज लैग बहुत ज्यादा था, कंटिन्यूटी एक लाइन सुन ही नहीं पा रही थी सर.
और सेकंड, अगर नेट थोड़ा सा लो है तो यू कैन स्विच ऑफ योर कैमरा.
ओके ओके सर, अगर आप कहें तो मैं दोबारा कनेक्ट कर सकता हूं सर इसको.
I think we would like to come back to him again, because I मुझे तो honestly I could not understand कि हुआ क्या.
Same sir, same here sir, same here, but due to internet connectivity this problem has come sir, but this is a very nice मतलब novice thing है, he has made on himself only without the support of anyone. So I just want कि आप इसका end में जरूर एक बार देखें sir.
So Tapas, we will come back to him again.
ठीक है, I am noting down sir. Mr. Piyush Agarwal. Yes, sorry, Kuswa.
So, and I think request to all other participants also. I think if we are all struggling on bandwidth, maybe we can just keep our video off, so maybe we get a better audio.
Correct. I think it will.
Yeah. I think Tapas, we should go to the next presenter.
Okay, sir. So next presenter we have Mr. Mithilesh Kumar Gupta, again from ABS University. Just a minute, I'm giving the screen share right to Mithilesh Kumar. Mithilesh Kumar Gupta.
Yes,
now
sir.
you are, yeah. Please share your screen for the presentation. I think you have now screen share, right? You can see the, yeah.
Sir, I am audible.
You are audible, Mithilesh. Can you coming great?
Okay,
So,
hello.
yeah, you're audible, and your now time is 4:52, and you can start now.
Okay, thank you, sir. Hello, good afternoon to all. My name is Mithilesh Kumar Gupta, and I am final year student of ABS College, and I am president of our ABS ISHRAE chapters. And now, before we start the presentation, I would like to recall my real experience which occurs to me when I went to hometown and I saw in the field of farmer problem to irrigation of the field. Then one idea comes in our mind to solve their problem. Then I select the small smart irrigation system using the IoT. And now, before we going to the our ideas, let's focus on the agriculture in our India. The agriculture in India is one of the most important sector that contribute our Indian economy. And most of the Indian farming are still the traditional method for farming, which been looked in view modern needs to fall short, also due to different climate condition. And now the availability of water for the agriculture differ in the different part of our country in order to the optimized solution for modernizing the irrigation problem. And now this presentation is based on IoT, which provide the solution of the above problem stated. And smart irrigation system using IoT covers the problem associated with water scarcity, poor productivity, and poor yielding of the crop, improper management, sustainability use of waters, and moisture. In my idea, moisture means the water molecule content present in our soils, and this is the main thing which required to crop the best crop in our farmings. Now this is the data table which we consider fine clay 80 to 100% means no required to the irrigation in our crop. And this is the medium clay, and also this is the coarse sandy 90 to 100%. And if required the irrigation 60 to 80%, then we need the sprinkle and motor pumps, and which is required in crop solution. And now this is the process flow chart diagram, which is so the first of all Arduino used. Then we sense the moisture content present in the soil, and probe is inserted to the soil, and moisture content is measured and then displayed to the LCD through the Arduino. And in my ideas, use the soil moisture sensor LM393, which is the Arduino means works on the all the physical activity parameters convert into the signal like display, buzzers, and etc. And this my idea, which this is the probe which directly insert in the soil, and this is the present to moisture content available in the soil. And now this is the LCD for the output signals, which is taken by the Arduino probe sensors. Now Arduino means works on the principle of all the physical activity convert into digital works, signals, buzzers through the controlling device of our signals. Now this is the circuit diagram of my project. This is the Arduino and LCD and moisture sensor LM393. And this is the some references which I got the complete my presentation. Earth observing system articles, soil moisture control essential farming, and the ideal moisture level of grow crops, and smart irrigation and weather. And now thank you.
Thank you, Mr. Mithilesh. And we are moving to the next presenter, again from ABES, and is Mr. Shivam Gupta.
Good afternoon, everyone.
Yeah.
I am audible?
Yeah, you are audible, Shivam. Just wait for a second.
Okay.
I'm transferring the screen sharing rights to you.
Okay.
Please share your screen, Shivam. Please go ahead.
Okay.
Just a minute. I think two names are coming. I mean, Shivam Gupta. I think.
Yes, sir. I also joined with
दूसरे
my
में
phone
just a minute. फिर दूसरे वाले में मुझे करना होगा ट्रांसफर.
because of there is a live demonstration for my project, so I connect devices, laptop as well as my phone.
Just please try again.
Yeah, 1 second, sir. Visible.
Visible. Fine.
Thanks, sir.
Go to the slideshow. Yeah.
So again, good evening, everyone. My name is Shivam Gupta. I am a student of ABS Engineering College, and I am studying 4th year in mechanical branch. So I am today. First of all, congratulations for Engineers Day, and my concept on anti-theft home automation based on IoT, and I totally complete this project under guidance of Mr. Saurabh. So starts with the introduction. Basically, IoT is the concept of where each device is assigned to IP address. Through IP address, anyone make the device identifiable. And so the recent developments in technology permit the wireless controlling equipment, like we connect the devices with Bluetooth, Wi-Fi, and others. So Wi-Fi shield acts as a microwave web server, which provide the stability or connection to device without any wire like we connect Arduino board and computer with our phone without any wire. So Wi-Fi still needs connection to internet or Wi-Fi wireless routers and hotspots. So basically, with this in mind, an internet-based anti-theft home automation system for remote control. I at that time I'm sharing a problem statement with which happens with me. There एक रात मेरे घर में एक कोई आया था और मुझे पता नहीं चला कौन था, तो उसको उस प्रॉब्लम को मानते हुए मैंने सोचा कि कैसे कर सकते हैं। तो हमने इसमें एक सेंसर के थ्रू हम सेंस करते हैं इवनिंग में, रात में जब गेट क्लोज हो जाते हैं कि कोई आएगा तो हमें उसका नोटिफिकेशन मिल जाए। तो उसी बेसिस पे मैंने ये सर्किट डायग्राम जो मेरा थिंकरपैड पे बना हुआ है। So there is this is node MCU which is Wi-Fi enabled and connected with 4-bar relays, and relays are connected with our programs or appliances which react. Basically, relays are circuit breaker and change get work with less power input. Next, this is the list of devices with specifications of my project. This is there is node MCU which is specification is 32-bit microcontroller and clock speed 80 megahertz, operating voltage lump sum 3.3 volts, and IR sensor which operate 3 to 5 VDC, and its range minimum 1 to 5 centimeters, and others components. This is the code of my project which works in, and this is circuit diagram again, which shows the flow of power supply to the end to component to component. This is CAD model of my project which I made and live demonstration. Now I am sharing some my live working of my project. So take a minute. So basically, this is working.
Shivam, your screen is, I think, disconnected. Please.
Sir, I stopped my just now. Stop my presentation, and I'm sharing a video.
Okay. Okay.
With Preet Chaudhary's phones. My friend.
I think so you have to switch the account.
What, ma'am?
Tapas, you have to
ठीक
switch.
है, वो कैमरा से मेरे ख्याल से वो
Yeah, ma'am. Phone camera. Yeah. Can I proceed, sir?
ठीक है, please go ahead.
Okay, thank you, sir. So this is basically working model which I made.
But it is not visible, Tapas.
Not visible. So.
शिवम थोड़ा कैमरे को पास लेकर आओ.
Okay, ma'am. Okay. Okay. Now it's visible.
मैम ये प्रीति चौधरी के कैमरा से ये सर्विस कर रहा है.
It's visible now. It's visible. Yeah.
Now it's visible, ma'am.
Yes.
So this is basically work on the phone connect, which is working on IR sensor based. So let's suppose this is our main gate, and a person going there, and buzzer will start like that. And there is this is battery IR sensor, and these are other appliances which are also operated by phone. So thank you all of one. That's all of my side.
Thank you, Shivam. Thank you very much. So we are moving to the SGT University. Just
अभी आनंद.
Tanuj Sethi.
Yes, sir.
Good evening, ma'am.
Tanuj Sethi is there?
Yes, sir.
Okay. Tanuj, now you can share your screen.
Am I audible to you also?
Yeah, audible, and it's 5:07, right?
Okay.
Your time starts now. Please go ahead.
So good evening, everyone present here. My name is Tanuj, and today I'm going to be demonstrating a project presentation on this auspicious occasion of Engineers Day on the theme of everyday engineering marvels in daily lives under the ISHRAE student chapter at SGT University. So the name of the project that we created in our university is Oxygen. This is the oxygen concentrator that we fabricated in our university itself, and we named it as an intelligent portable oxygen concentrator. So why we made oxygen concentrator in our university, because we gauged different problem statements. Because during the time of COVID pandemic, we found out that there was shortage of oxygen concentrators and ventilators. Since oxygen concentrators were being only connected to one person at a time, and due to some sort of infection known as coronavirus, if that sort of device got infected, they weren't being used afterwards. And most of the concentrators didn't have any feedback loop with their users in which they are being used. And there were lots and lots of external devices for health monitoring softwares that were being attached with the unit. So we came up with a solution to increase the liter per minute of the oxygen concentrator, as traditionally the concentrators that are available in the market comes with 15 liter per minute. We devised it for 30 liter per minute. We used UV light to cure each and every part that were used inside the air loop system. We used zeolite crystal for adsorption and silica for removal of humidity, since the oxygen concentrator is based on pressure swing adsorption. We, moreover, integrated SpO2 sensor and oxygen analyzer for determining the oxygen concentration, and light indicators for visual information. As you can see, the working of project now. First, the oxygen, like the air, gets compressed from these compressors and gets transferred to the cylinders via evaporator. This one cylinder is dedicated for adsorption, and these two cylinders basically are for adsorption, and this cylinder is dedicated for reservoiring or sourcing out the oxygen that is being developed by these two cylinders. This is the dehumidifier container, and this is the FR unit. FR means filter and regulator unit. Moreover, we have devised an oxygen sensor and a flow rate sensor, which helped us in gauging out the flow as well as the concentration of our unit. And this is the video demonstration. And this is the testing that we did at our National Simulation Reference Center at SDT University. And we found out that the oxygen concentration that we are getting was of 96% at 30 to 29 lpm. So our findings, we managed to get an output of 29 to 30 lpm. We have managed to get the readings of 96% of O2 concentration at the output of 29 liter per minute. We have integrated pressure sensors with the endotracheal tube, which will help in cutting off the oxygen supply whenever needed. And activities that we have planned further under the ISHRAE student chapter are organize an industrial visit in industries affiliated with ISHRAE, to conduct awareness drives in the villages nearby SGT University, to teach the villages about the benefits and applications of the oxygen concentrator that we have fabricated in our university, and organize student development workshops. So this is it from my side. And this was the team members that together have made this project a success under the faculty advisor of Mr. Dinesh Deswal sir and Amit Jangir sir. So that's it from my side. Thank you.
Thank you, Tanuj, for your presentation.
Thank you, sir.
Now we have Mr. Avay Anand from same university.
Yes, sir. Good evening, sir.
Yeah. So just a minute away. I'm transferring the sharing rights to you. Yeah, please go ahead.
Sure. Sir, is it visible or not?
Still not.
Give me a second. I will check it.
Your video is coming only.
Yes, sir. Give me a minute, sir. I'm checking it out.
Again, share your screen. Okay.
Just a second, sir. Actually, I am having some internet issues, so I'm trying to show it on from my camera screen.
Okay. The camera screen is will not be visible anymore. I mean, that will be not workable. So one option is that you can mail us. We will share from here.
Just a second, sir.
Are you in the engineers group that we have met today? WhatsApp group?
Yes, sir. I am sharing on that group.
Yeah,
Just give me a
share
second.
on that.
Yes. I can share it, sir. Can you please check it out? Hello, am I
I have
audible?
received it. Just a minute, I'm sharing this.
Okay, sir. Thank you, sir. Thank you so much, sir. So first of all, shall I start, sir?
Please go ahead. It's 5:16 and your time starts now. Please go.
Oh, thank you, sir. So first of all, very delightful good evening to all anyone present here, and happy Engineers Day to all the engineers present here. So on the occasion of Happy Engineers Day, and to make our society like a very successful, delightful future, here we can introduce the e-cycle, or we can say that the electric cycle, also attached with the solar panel to get the power from the solar panel. First of all, there is an pointed what is an e-cycle or an e-bike. Basically, the e-cycle or the e-bike is a motorized bicycle with an integrated electric motor that is used to assist propulsion, which means कि हमारे पास जो भी हमारी साइकिल है और हमारी बाइक है, we can say that हमने जो भी आजकल साइकिल्स देखी हैं, we can say that कि pedals हैं, we pedal them, then they move or what. But if we want to transfer them and if we want to make and convert it into the electric cycle, then we have attached here. What we have to do, just we are creating that we are using a brushless DC motor and the battery. Here we use the battery for 2 battery packs. Each one is of 12 volt, and the batteries are used are maximum uses of batteries in now industry is lithium ion batteries, because lithium ion batteries are worth it चार्जिंग कैपेसिटी ज़्यादा होती है, हमारे पास टाइम कम लगता है उन्हें करने के लिए, एंड मैंने तो रिप्लेसेबल भी होती हैं और सेल्फ रिचार्जेबल भी होती हैं। बट हमारे पास यहाँ नया जो हमने इंट्रोड्यूस किया है वो हमारे पास है कि हम इसे सोलर पैनल के थ्रू भी चार्ज कर सकते हैं। इट बी जस्ट लाइक कि 2 आवर्स लेती है हमारी बैटरी जो है वो इसे चार्ज होने के लिए। देन इसकी जो 15.5 माइल्स तक की एवरेज हमने निकाल रखी है, ठीक है। हम इसे लोकेलिटी, नियर बाय लोकेलिटी फॉर एल्डर पीपल्स, मतलब उन्हें जाना है, नियर बाय शॉप में जाना है, नी पेन है या कुछ भी है, वो जब इसे शॉर्ट रेंज के लिए यूज कर सकते हैं। एंड हियर वी आर आल्सो इंट्रोड्यूसिंग दैट जो हमारी मोटर होगी और जो हमारे पास कंट्रोलर होगा, वी आर यूजिंग द स्टैटिक मोटर सो दैट अगर हम पैडल करें तो while on paddling it produces the kinetic energy, and that energy produced into the heat energy and confirms that it can surely make the chemical bondings and to produce the energy that will charge the battery on itself while paddling. Here we have some specifications in all the countries about the e-bikes and e-cycles. If we are talking about the battery charging power input, it's like 500 watt hour to 250 watt for 2 hours, and for 500 watt for 1 hour, and for 1000 watt it is in on 30 minutes if we increase the speed or what. There are two options we have, one of pedicle cycles and one is of working on throttle. The throttle one is that we have to just synchronize the throttle with the motor so that it can give us the output, but while as on pedals we have to
Abhay, just a minute. You can tell me which slide. I mean, this is slide one only, first one.
Sir, it's slide 6th.
So you should tell me na ki move the slide, or otherwise it was, I mean, anyway. Is it?
Yes, sir.
So one slide is over. Tell me, move to the next one.
Yes, sir. Yes, sir. Here we can see that this is our the working model presently at SUT University. We can testing on this. यहाँ पे हम हमारी सोलर पैनल है वो हमने माउंट कर रखी है, एल्स हमारे पास नीचे जो हमारी मोटर है वो भी माउंटेड है, एंड आगे क्रॉस पैडल सेक्शन के ऊपर हमने हमारी कंट्रोलर रखा हुआ है। बेसिकली हमने जो लिथियम आयन बैटरीज यूज किया है, इट्स फॉर ओनली वाई डेट कि ये रिचार्जेबल होती हैं, सेल्फ रिचार्जेबल है, इजिली रिप्लेसेबल है, एंड इट इज ऑल्सो नॉट मोर हार्मफुल टू द नेचर टू मेक द नेचर ग्रीन, environment green and secure. Electric vehicles or electric cycles or electric bikes are important, as our government is also now focusing on electric vehicles because they are also giving subsidies on electric vehicles. So we are here with an idea to introduce an e-bike or e-cycle that is also being powered by or charged by the solar panels. And here the chart is shown. It is the chart of the countries with having how much subsidies they got and how much range or number of e-bikes or cycles they are currently situated. Sir, can you move to next slide, please?
We have only 30 seconds left.
Yes, sir, I am on it. I am done. So here's the last option, that regeneration of power by pedaling the cycle and to create the kinetic energy and to convert the kinetic energy into the chemical energy. So thank you all of you for listening. Thank you, sir.
Thank you, Abhay, for your nice presentation. I think Mr. Ashwani Rai had not done in a proper way the presentation because due to network issue. So I'm going to share. Ashwani Rai, are you there?
So can we start through Mr. Piyush Pushpa first?
Yeah, Piyush Kushwaha, can you share the presentation of Piyush Kushwaha?
Hello, sir.
Piyush, can you share your presentation in that particular
Sir, I
group
am audible?
that I was, yeah.
Yes, sir. Yes. Sir, it's showing host as disabled participant
No,
screen sharing.
I'm asking to share the presentation in WhatsApp group. I will share the screen. You will have to speak on.
Okay, sir. Okay. I'm sharing. Okay, sir. Yes, sir.
Or anyway, if your network is now fine, then you can check with your share screen also. Piyush, can you check with your screen only? If it is fine, then we can.
Yes, sir. I'm checking. Sir, is it visible?
Yeah, it's visible. Yeah, your voice is also.
Can I, sir?
Yeah.
Okay, sir.
Please go to the slideshow mode.
Good morning, all. Good afternoon.
Yeah.
Yes,
Right.
sir.
So it's
on.
5:24, and
Sir, it's
you can
in
use your
slideshow.
7 minutes. Yeah, please go ahead. Please start, Piyush.
Yes, sir. Good evening, all. I am Piyush Kushwaha from Mechanical Department and member of ISHRAE ABS chapter. And today I am going to present on my project 3D printer. So 3D printing is a additive manufacturing technique which make anything by layer. Since 3D printing is a additive manufacturing technique, 3D printed part will take only that much amount of material which is required to build that part. Unlike CNC machine or any conventional milling machine, lathe machine, which needs a block of material that is of bigger size of what we need, and we have to use that machine to cut away that block of material until we have the shape and size of our required material, required part. So the cut just goes to waste. That's not sustainable and waste of resources. On top of that, 3D printed part can be used can use as much as material as needed. You can see here in video, it is hollow inside. So we can change the setting as per the strength requirement. And now coming to next slide, getting from idea to real 3D printer. So first I designed in CAD software. CAD software is used to develop design, used in development of design and analysis and manufacturing of these things. It improves our accuracy, and we can tinker small things and see what we have to build. It's very helpful and require very good, but it require good knowledge of CAD software. And designing whole machine in CAD improve the accuracy, as I say. So first I started designing in CAD and started by X, Y, and Z axis. These machine work on 3 axes named after 3D printer. So and build whole frame upon that. Now next part is the assembly. The CAD part, the CAD modeling and software and designing part took almost 1 month to designing and optimizing the structure, shape, and size of the printer. And then after completion of a CAD model, I started assembling the printer. I first I first buy all these things from open market and use this thing to build a printer. Here you can see image of my printer that I have built, and this is the CAD model, and this is the real printer. It's and the final setup. In the video, you can see it's building a switch, a power switch, and it's a layer by layer process, and it uses a Raspberry Pi. Z-axis, one X, one Y, and one extruder. As you can see in this video, a filament has been forced into the hot zone of the printer, and it melts, and all the three axes are moving simultaneously to build a 3D object. And special thanks to a huge online community of desktop 3D printer, where all around the 3D print all around world 3D printer user come together and solve problem of each other. So I appreciate that. And now why I am so passionate about 3D printing will take production and turn it toward it the local level, and so the company doesn't have to make products anywhere else and then transport it to where the market is. And 3D and the 3D printer can produce very cheap medical prosthetic hands, the real prosthetic hands which are available in the market are very expensive these days, and not each of people with disabilities can afford to buy this prosthetic hand. So 3D printer can change that and make cheap, very cheap and working prosthetic hand.
1 minute left.
And 3D printer will save the environment. It is using as much material as needed. No scrap material is formed. And 3D printer, sometimes 3D printer accept only recycled material. Like we can recycle plastic again and again to make different things. After end of use, we crush that and remelt it and make another thing. And 3D printing for sustainability. As you can see, it's a heat exchanger. It has two fluids coming from this side and an internal very complex shape to exchange heat. So not any conventional machine can produce these type of complex internal shapes. Only 3D printer can produce by layer. So it's so 3D printed heat exchanger have very high thermal exchange and low weight, low pressure drop. He, and nowadays GE Aviation, a jet engine manufacturer, uses 3D printed fuel injector, which which weighs 25% less and uses and increase the fuel efficiency by 1%. That's a very huge achievement for the world. Yeah, it's reduced the emission. Thank you. That's all from my side.
Thank you, Pius. Thank you very much. I think we all done. Is anybody left for the presentation? They can raise your hand.
मोस्टली सारे स्टूडेंट्स कवर अप हो गए हैं सर। यू डी क्लास पार्टिसिपेट ही नहीं कर रहा, तो मोस्टली सारे स्टूडेंट्स कवर।
अगर हमने सारा कर लिया तो आई थिंक over to you, ma'am. I would like to hand over to Jan, ma'am, from here onwards. Priyanka, ma'am, are you there?
प्रियंका मैम अभी 2-3 मिनट्स में ज्वाइन कर रही हैं।
Purnima, are we going to announce the result in this forum or?
सर वेट अ मिनट, मैडम अभी कलेक्ट कर रही हैं और अभी कर रहे हैं, अनाउंस कर रहे हैं।
तो आई थिंक वी शुड अनाउंस ना कि वेट करना है, क्या करना है।
मैडम थी नहीं ना सर, अभी लाइन पे मैडम आई है, अभी वो अनाउंस कर रही है।
ठीक है, प्लीज।
I would like all the judges to speak something to the students. Adan, Amit Kaushik, if you can speak something with the to the students.
Purnima, am I audible? Hello.
Yes, yes, you are audible.
Hello. Hello.
Sir, you are audible, sir. Kaushik, sir.
Ji.
You are audible.
Okay. Yeah, good evening. Myself, Amit Kaushik. Yeah, am I audible?
Yes, sir.
I am audible.
Fine, sir. Fine.
Okay. Yeah, good evening. Myself, Amit Kaushik, and I am one of the judges in the today's program. And it's a very good initiative done by ISHRAE Delhi chapter, especially on the Engineers Day. So today we are celebrating Engineers Day, and this is the best way I think we are celebrating. And we have gone through the presentations given by all the students, and it's a nice to be a part of this program. And presentations are very good. All participants has given their excellency, and it's very hard to differentiate which one is good and which one is but anyway, finally we have to give some numbers. So very good presentation. So we will move the scorecard to the Purnima or Tapas. We are sending you the scorecard, Tapas. So accordingly you can announce the results.
Okay, sir.
Okay, that's all. Thank you.
Hi, good evening, everybody. Am I audible? Tapas sir.
Yes, Akash ji, you are audible. Yeah.
Yeah, thank you so much. So, hi everyone. Akash Saxena this side, Youth Chair Daily Chapter of ISHRAE. I hope all of you are fit and fine. So, on the auspicious occasion of Engineers Day, I wish a happy Engineers Day to all of you. And as Ashish sir very rightly said at the beginning of the session, we should be proud to be engineers. I'm an engineer too, BTech Mechanical. So as Ashish sir said, most of the innovations are done by engineers only. So अगर engineers हैं तो सब कुछ है. आप आज की डेट में कुछ भी देख लो, जो भी चाहे बड़ी से बड़ी बिल्डिंग बन रही हो, कितनी भी इनोवेशन हो रही हो, एआई आ रहा हो, कोई भी टेक्नोलॉजी आ रही हो, हर चीज में इंजीनियर्स का एक पिवटल रोल रहता है. So yes, we should be proud that we are engineers and we should strive to contribute more and more toward the society. And coming on to the today's session, all of you were great today. I'm very happy that so many students took part in the event today, and it's really good to see more and more of you are trying to be the best. And the competition was really well. And जीतने से better सबसे बढ़िया ये है कि at least you tried. Many of the students I know didn't even try to be the part of this session. So all of you tried. This is a really good thing, and all the best to everyone in their future endeavors.
Thank you, Akash ji, for your nice word. And in between, I would like to say this program is sponsored by Ventilier, and we are very much thankful for Ventilier for sponsoring this program.
Hi everyone. We just need 5 more minutes to announce the results. Just be patient. We are just announcing the results.
Please camera on, all students अपना camera on कर लें for result announcing के लिए. Request to all students, please. Mithilesh, Shivam, Piyush, it's a request, please switch on your camera.
So it was a very good effort done by all the students, I will say. And whoever showed the live project, we will really appreciate the work. And we were expecting that only. So now just don't take it anyways, because it is a competition. So we have to declare the results for that. And but all of you have performed really good. So now I will announce because a basic average of all the judges, what they have given the score to after your performance. So now third prize goes to Abhay Anand from SGT University. Congratulations, Abhay. You got the third prize.
Thank you, ma'am. Thank you so much, ma'am.
And the second prize goes to Mithilesh Kumar Gupta from ABS University. Congratulations, Mithilesh.
Thank you, ma'am. Thank you so much, ma'am.
And the first prize is Tanuj Sethi from SGT University. Congratulations, Tanuj.
Thank you.
So I, on behalf of Delhi chapter of ISHRAE and the organizing committees, extend a heartily vote of thanks to Mr. Amit Kaushik ji, Akash Gupta ji, and Mohammed Adan, sorry, I'm so sorry, who took out valuable time from your busy schedule. We would like to express our sincere thanks to the teachers who encouraged their students to be the part of competition. And we would also like to thank our DCI President Ashish Gupta ji for encouraging us to do this special competition on Engineers Day. And no other program can be successful with a single person. So I want to extend thanks to the complete team, Purnima, Tapas and their team, for making this a big success. Thank you, everyone. Thank you so much.
Yes, a request to all judges and students, please, faculty member, please switch on camera for photo. Amit sir, Akash sir, please.
Purnima, there is some problem with my
Yeah, it's not an issue. Koi issue nahi. Okay. Tapas sir, please. Thank you everyone.
So should we close this session? I think, Amit sir.
Yeah, sure. Thank you.
Okay, thanks
to all.
for coming, sir. Thank you very much. Thank you, everybody.
Thank you, sir.